so this our architecture of 8086 microprocessor. Okay, all are clear?
Yes, sir.
Yeah, yes, sir.
Yeah, here.
Yeah, clear.
Abdulhamid.
Yes, sir, clear.
Okay, so now our second topic, register structure of 8086 microprocessor. This is the block diagram or architecture of 8086 microprocessor. Now register architecture or register structure, only register. You know, oh, these all are registered, okay? And this is the flag register, okay? And this also, this is the register, okay? But this is the internal communication register and temporary register. This not main register, okay? So this your only this the register, this and this, okay? So now our register structure, this your register structure, okay? So this, only this part, okay? Register structure means only this part, okay? Clear? All are clear?
Yes, sir.
Register structure means only this. So this your main structure. So this is the general register and stack pointer, two stack pointer and two index register, a source index and destination index pointer are two, stack pointer and base pointer, and general register are 4 AX, BX, CX and DX. These are 16-bit. If you use 8-bit, then AS or AL, BAs or BL, CAs or CL, DAs or DL. If you use 16-bit, then AX, BX, CX, DX. Okay, so this your execution part, and another execution part is the flag register. Okay, and bus interface unit part, this is the 4-segment register: code segment, data segment, stack segment, extra segment, and another this is the IP, instruction pointer. So this your total register. Okay, this part, this your total register. This is the general purpose register. This is the stack pointer, base pointer, destination index, source index, flag register. Okay, and IP, instruction pointer, and 4-segment register. Okay, so this your register architecture. At first, draw the register architecture, then discuss general purpose register, all register, resistance part discuss, then pointer register discuss, then index register discuss, then flag register discuss, then segment register discuss, and IP, instruction pointer discuss. Okay, clear? All are clear? So already this including our register architecture. So you are completely study register architecture, then main architecture of 8086, then register architecture is very easy. Okay, register architecture is the part of our main architecture. Network সমস্যা তোমার। Sorry? হ্যাঁ মিথুন।
না স্যার, আর মাইক্রোফোন হাতে চাপে অন হয়ে গেছে।
হ্যাঁ হ্যাঁ
না
কথা বোঝা যাচ্ছে না।
মাইক্রোফোন হঠাৎ হাতে, কোনো সমস্যা নাই স্যার।
তোমার কথা কেটে কেটে আসছে, আমি কিছু বুঝতে পারি না। So this your register architecture. Okay, this your register architecture. Only register architecture. If your question register architecture, then discuss this part. This is the 0 to 7, this is the lower order, and 8 to 15, this is the higher order. And if you use AX, then 0 to 15. Okay. So this is your general register. This stack pointer 0 to 15, all registers 0 to 15, 0 to 15, 0 to 15, all are 16-bit. Only this ALH, BLBH, CLCH, DLDH, these are 8-bit, 8-bit. Okay, but all are 16. Okay, so this is your register architecture. At first, draw register architecture, then discuss this step by step, this part. Simple 2 or 3 lines discussion. Okay, these are segment register. So segment register, just discuss. This is the huge discussion, just 1 or 2 line discussion of main part of code segment. Okay, then data segment, stack segment, stack segment. Okay, so this part clear. Register structure. Now another part is your this is the register structure all discussion. This is the very important. Another topic is your flag register. This flag register. Okay, this, you know that flag register are also 16-bit, 0 to 15. Okay, 0 to 15 flag register. Now we discussion flag register. Flag register. This is the 0 to 15, but all are not used. Okay, these the only nine flag are used, but these are not used. Okay, these 7 are not used. Only 9 are used. So this the study formula, this my formula, this is the ODITS, audits, ODITS, audits, JDA, JA means go, audits go. Okay, audits JA PC. Okay, this is the PC. Audits JA PC, this is my formula. Okay, audits JA PC. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these O are starting our 11 number position. Okay, O D I T S, audits Z A, at this is the space, JA space means one gap. Okay, audits JA, then PC, audits JA PC. Okay, P, then space, then C. Okay, so this is your formula, audits JA PC. All are clear?
Yes, sir.
Yeah, here.
Yes, sir. Clear.
Okay, thank you. You are not here.
Yes. Okay, sir.
Okay, sir. Okay. So now this different part. This O means OF, F means flag, DF, F means flag. Okay, O flag, D flag, ODITS, ZAPC. So now we start. A means C means carry flag. C means carry flag. You know that carry. Our suppose addition to value. If you want to carry, then this the carry flag is high. Okay, this position is high. If this position is high, microprocessor or acknowledge this result is must be carry. Okay, so this is the flag, carry flag. Okay, this is the parity flag, parity bit. Or you know that parity is 2 types, odd parity and even parity. Parity means suppose this the value, this value maximum 1 is 5. Okay, 1, 2, 3, 5. 1, 2, 3, 4, 5. Total high or total 1 number of 1 is equal to 5. So 5 is odd. So this parity is odd parity. And suppose 1, 2, 3, 4, 5, 6. So this 6, number of 6, 1. So these are even parity. Even, okay, even parity. Okay, so this is the parity flag. Okay, this is the parity. Yeah, parity flag.
Yes, sir.
This is the if high then even number. This is the low then odd number. Okay. Then this is the auxiliary carry. Auxiliary carry, this is the after 4 bit carry, this called auxiliary carry. Okay. Suppose this is your math.
Right.
Okay, suppose this math addition. This is the 0, 0, 0, 1, 1, 1, 0, 1, 1, 0. This is the 1, 1, 1, 0. This is the 1. This is the after 4 bit parity, after 4 bit carry. This is the finished 4 bit. Okay, then carry 1. After 4 bit carry, this called auxiliary carry. Okay, now this 1, 1, 1. This is the 1. Then now this 1, triple 1, this 1. Now double 1 is 0. Now double 1, 0, 1. So this your data. Okay, but this the auxiliary carry, and this the carry. This carry is normal carry flag carry, and this is the auxiliary carry. Okay, after 4 bit carry, this carry is auxiliary carry. Okay, all are clear?
Okay, sir.
This is your auxiliary carry. This is the nibble. 4 bit data called nibble. 4 bit called nibble. 8 bit called byte. 8 bit called, this is the 1 byte. Okay, 1, 2, 3, 4, 5, 6, 7, 8. This is the single bit. Total number of 8 bit called 1 byte. Okay, and 4 bit called, this is the 4 bit. This 4 bit called nibble. BBL nibble. Okay, all are clear? So this borrow. Okay, addition. This is a carry lowest nibble. Okay, after 4 bit carry or 4 bit borrow. Okay, this is called auxiliary flag. Okay, clear? All are clear?
Hello, sir.
Yes, sir.
Hello,
Yes, sir.
sir. Nipple. What means?
Sorry,
Nipple.
nibble.
Yeah.
Nibble means, you know that 8 bit is equal to 1 byte. Okay,
Okay.
8 bit is equal to 1 byte. Then this another point, 4 bit is equal to 1 nibble. 4 bit. Okay, 4 bit is equal to 1 nibble. And 8 bit 1 byte. Okay,
Okay.
all are clear? 8 bit 1 byte and 4 bit nibble. This is the after 4 bit. Okay, this is a nibble addition.
Sir, 3 bit equal 3 bit.
No, not 3 bit. Okay.
স্যার নেবল মানে কি স্যার এখানে কি বোঝাচ্ছে?
কি বললাম তোমারে, বাইট মানে কি? বাইট মানে তো বাইটই নাকি?
জি স্যার।
নিবল একটা নাম, বিট মানে বিট, সিঙ্গেল ডিজিট কল্ড বিট, 4 bit called 1 nibble, 8 bit called 1 byte. Okay,
স্যার
clear?
জি স্যার।
Then another zero flag. Zero flag means if your result all result is zero, then this flag is high, zero flag. Okay, this is the zero flag. And this is the sign flag. Your result negative, then this is the negative result. Your result is negative, then this point is high. Okay, or if your result is positive, then this sign flag is zero. Sign means assign the negative or positive result. Okay, then another trap flag, then interrupt flag. Okay, trap flag. This is the processing part. Okay, the processing part, a signal step execution mode. Okay. This is the generating internal interrupt after the execution of each instruction. Internal interrupt. This is called trap flag. And this is the interrupt flag. You know that interrupt. Okay. This is called interrupt flag. If anyone does interrupt this microprocessor, then interrupt flag is high. Then direction flag, incoming outgoing direction. Okay, this is the direction flag. And this is the overflow. If the overflow, okay, extra result. Already our previous math overflow. Okay, this suppose this 1, 2, 3, 4, 5, 6, 7, 8, and another. Suppose this the addition 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, then this one. This one is the extra carry, but our system is 8 bit, all are 8 bits. This is the 9 bits. So this one is overflow. Okay, clear? Overflow. Okay. Clear? So this your flag register. Okay, all are clear?
Yes,
Yes sir.
sir. Okay.
So this is the register structure. Okay, this full register structure. This is the general register. This is the stack pointer. This is the summary register structure summary. This general purpose register 16 bit. This is the AX, BX, CX, BX. General purpose register 8 bit. Then AL, AH, BL, BH, CL, CH, DL, DH. Pointer register 16 bit. 2 SP and BP, stack pointer and base pointer. Index register 2, source index and destination index. Then instruction pointer, IP, instruction pointer. Then segment register, code segment, data segment, stack segment, extra segment. Then flag register. This is the flag register. Okay. So this your register structure. And if you discuss the register structure, then this is not discussion, this is the summary, register name. But a discussion, then how to work general purpose register, how to work stack pointer, base pointer, or pointer register, or how to work index register, how to work flag register, and how to work segment register, and how to work instruction pointer. Okay. Total discussion, this is the register structure. Okay, and register structure category wise division. These are 4 groups: 1, 2, 3, 4. Okay, clear. This is the special function, small description. All part is small description. Previously described, fully described all part. Okay, but this is the summarize. Okay, this is the summarized description. How to work the register. Okay. So today our architecture finish. Clear?
Yes, sir.
Okay. So you know that today our another class is the lab class. Okay. So now this day we are complete the some lab purpose description. Okay.
Okay, sir.
Okay, sir.
So now this day our main lecture, theory lecture finish. Now we start lab lecture. Okay.
Okay, sir.
But only 5%. Monir, Deva, Mithun. Only 3 Bengali students and only 2
Hello, hello,
Somali.
sir, and
Hello,
hello, sir,
hello.
and Abdulhamid, Somalian Abdulhamid,
Yes,
for 17, for 10, and for 12, and for 14.
yes. But now only present you enroll train Ismail.
Yes, Abdulhamid is now is what he's talking you, but I don't know what happened.
Yes.
He's in a class. He's still
Now this present only 5%.
okay, sir.
Today our class very important part, lab part.
Yes, sir. Okay.
You know that this semester our subject is very hard subject
Okay, sir.
because this subject is 2 parts, microprocessor and microcontroller. This
Microprocessor.
subject, this subject we use 3 software. Okay, 3 or 4 software using this semester. So these are very difficult and very interesting subject. Also, this subject is very interesting. If you understand, then this subject is very interesting. Okay,
Okay, okay,
and
sir.
this subject is very important subject in our life because you know that our all system are automated. All system are automated.
Okay,
Okay,
sir.
if
Okay.
you need automation, then must be knowledge our this subject microprocessor and microcontroller. So
Okay.
this subject is very important.
Okay, sir.
Okay, so
Lab.
but all the students are inactive. Only 4 and 5 student is active. Okay,
Hello.
regular you then Abdulhamid, Ismail, Mithun, Monir, Deva. Just this person is active, but another all are inactive.
Sir, it's the last time. Next time, all students will be attending class
So
as
because
so,
this
yes, sir.
subject, if you another institute just extra course, okay, extra course, short course, okay, short course, just microcontroller you study short course or of another institute, then this short course price minimum 16,000.
Oh, so
Okay.
so expensive.
So expensive short course. Yeah, and this subject is very important your life. So all are at least last semester must be needed this subject. Then all are searching other institute who this institute are short course the microcontroller. Okay,
Okay, okay, sir.
but if you active this semester, no need the short course.
Okay, sir.
I promise.
Okay,
With
sir.
extra efforts this subject. Okay,
sir.
microcontroller. I thoroughly discussion microcontroller is very interesting subject.
Okay, sir.
Okay, so must be
Sir, negative time.
discussion your another friend. This
Yes.
subject is very important, and this subject must be needed in our practical life.
Yes, sir.
So
I will
so yes.
I will be talk also Marian,
Yes.
inshallah. Okay, sir.
And also Monir, Mithun,
To
দেবা
connect.
তোমরাও একটু ওদের সাথে কথা বলো বাঙালিদের সাথে এই সাবজেক্টটা কিন্তু খুবই ইম্পর্টেন্ট এই যে তোমাদের ফাইনাল ইয়ারের ডিফেন্স আসবে ফাইনাল ইয়ার প্রজেক্ট সাবমিশন দেন মাস্ট বি নিড দ্য মাইক্রোকন্ট্রোলার because all section if you used power plant, if you used power electronics, if you use substation and everything or automation system and another every automation system, electronics part, electronics device part, every part using the microcontroller. Now, okay, because this world is updated world. Okay, all institute are used microcontroller based automation. All are automation. Suppose you are joining in one institute. This institute at first automated your fingerprint. If you finger, then your attendance active. Okay, so first part your automated. Then another automated your security room. If you punch finger or password, then open the door. Then this another automated part. Okay,
Okay, sir.
your suppose your room control or your AC fan all are controlled automated. So this subject is very interesting. Okay, so all are must be active this subject. If you not active, then missing these topics. Okay. কি মনির বুঝাই মিথুন
জি স্যার বুঝছি স্যার
so we are quickly finish microprocessor part, then start our microcontroller part. Microcontroller is very important our life. Electrical and electronics engineer are must be knowledge the microcontroller. Okay, so microprocessor just summarize, okay, some discussion, only thinking this part how the work microprocessor. Okay, then we are transfer quick transfer the microcontroller part.
Hello, sir.
Yes.
Next time I will be promise also Marian attendance
Yes.
well, inshallah.
But another our Bengali student also absent. Okay, so all are must be thinking this subject is very important subject our practical life.
Sir,
Yes.
today our lab is very important, but student absent. How?
Today our lab, this lab is not microcontroller lab. Today our lab is microprocessor lab. This is not important our microcontroller part, but this is the important, okay, because how the work microprocessor, okay, we need. So
Yeah.
just now our my topics, another topics, okay.
স্যার ল্যাব ক্লাস তো
হ্যাঁ হ্যাঁ বলো। এখানে problem হ্যালো
হ্যালো স্যার।
হ্যাঁ শুনতে পাচ্ছ? মনির
জি
কি
স্যার।
হচ্ছে? মনির আসছে যাচ্ছে?
ওর নেটে সমস্যা করে স্যার, ওদের এখানে নেটে প্রচুর সমস্যা করে।
Okay, so today
থাকি বাইরে যায় আবার মনে করেন নেট কানেকশন পাই এরকম করে।
আচ্ছা ঠিক আছে, সমস্যা নাই, বাট কন্টিনিউ করো। হ্যাঁ, okay, so now today our another topics 8255. At first study this, now then start our lab, okay. 8255. 8255, this another IC, this the IC name PPI, programmable peripheral interface. PPI, programmable peripheral interface. Okay, all are clear? This the suppose this our microprocessor, this our microprocessor 8086, this our microprocessor, and suppose this our input output device, okay, and these are suppose output device, input device means keyboard, mouse, okay, scanner, this we already use Wacom board, this is the Wacom board, okay, these all are input device, okay, and output device, you know that our monitor, printer, this is output device. All are clear? But this input device not directly connect our microprocessor, or output device not directly connect our microprocessor. Okay, all are clear?
Yes sir.
Suppose our Somalian student Ismail or Yahya, you are not directly connect Somalian and Bangladesh. You are must be use the port, okay, and using the rules and regulation. At first you need the passport, visa, then an observation, then and your checking, then passing Bangladesh. Suppose this is the Bangladesh and this is the Somali, okay, not direct connect, then connect must be need the port, okay, airport, okay, then this is the communication part, this is the main part, two countries communication part. Then another, this the microprocessor and this the input output device, this not directly connect. This microprocessor involve another IC. This IC is the port IC, okay, this is the port IC, this IC 8255, programmable peripheral interface, peripheral device. This is the input device and output device called peripheral device. Input and output device called peripheral device. Okay, so this peripheral device are interfacing at first this IC PPI, then PPI connect microprocessor. Okay, clear? Or microprocessor to output device. Microprocessor connect at first PPI, then PPI connect output. So all are clear? PPI. Hey, Deba,
জি স্যার
বুঝতে পারছো?
জি স্যার
PPI টা বুঝতে পারছো? PPI, programmable peripheral interface, peripheral device interfacing
জি স্যার
controller. This is the programmable peripheral interface. Okay, microprocessor assign this IC work to port communication. Okay, peripheral communication, peripheral device communication IC, peripheral device communication IC number 8255 of using 8086 and 8088 microprocessor. 8086 and 8088 microprocessor peripheral device, peripheral communication device name IC number 8255. Okay, then this Yahya, you are clear this?
Yes, sir.
Yes, sir.
Okay, thank you. So now we understand the PPI, programmable peripheral interface. Okay, this is the PPI, programmable peripheral interface, is the IO port chip used the interfacing IO device with microprocessor. Already discussed this. Okay, this is the peripheral and IO device interface part. Okay, clear? Interfacing IO device with microprocessor, interfacing. Okay, very commonly used peripheral chip and knowledge 8285 essential student in this microprocessor lab for the interfacing experiment. Interfacing experiment must be needed the 8255. Okay, clear?
Yes, sir.
Yes, sir. So 8255, just now we discuss 8255. This is the 8255 IC. This IC also, this IC 14 pins. Okay, this IC 8255 IC 40 pins. Number of pin 40. Okay, and just this number of pin eight two five five PPI. Number of pin 40. 40 pins. Okay, and this IC are using the port, 3 ports. Okay, communication port are 3. Okay, number of port is equal to 3. This port name, port A, port B, and port C. Okay, all are clear? This port, communication port A, this A port are 8 pin. Okay, A port PA, port A 02 PA 7. Okay, total 8 pin of 8 port, and Another B port also 8 pin, port B0 to PB7, and also C port 8 pin, PC0 to PC7. Okay, so total how many pin are used in port? 3 into 8 or 8 into 3 equal to 0.4 pin. Use the 0.4 pin. Okay. Sorry. Yeah. So suppose this is the missing this line. So total port PA0 to PA7, PB0 to PB7, PC0 to PC7. How many pins? 24. Okay, and this port another data pin, data pin D0 to D7. This is the data. These another 8 pins. So total 32 pins complete. Okay. Now another pin VCC1, ground 1. So these are 2 pins. Then chip selector. This IC selector pin. Another pin is IC selector pin. This is the new pin. Chip selector pin. This also bar pin, because this is the negative sign is active, means 0 voltage active. CS pin. Chip selector pin 1. Then reset pin 1. Okay, then address pin A0 to A1, A0 and A1 address pin. Okay, assignment address. Okay, so these are 2. Okay, and read pin and the write pin, WR. You know that read write. Okay, A0, A1 read write. Reset chip selector. This is the 6. Okay, this 6 and this 2, 8. So 32 and 8, total 42. Okay. All are clear?
Yes, sir. Yes, sir.
So our total pin, this not sequentially assigned. These are all A is this main pin diagram of 8255. Just this. Eight two. This is the main. Okay. Okay. This total 40 pins. This 26 number pin VCC is not clear. This is okay. So this your port A, 8 pins, port B 8 pin, port C 4 and 4, port C 8 pin, then D0 to D7, this is the 8 pin, and this also 8 pin, total 40 pins. This is the 40 pins. All are clear?
Yes, sir.
So this microprocessor this is the um, uh, architecture of 8255 PPI. Okay, this also assign our this. Okay. This architecture, you know that our this processor is 40 pins and port PA0 to PA7, this is the port A, PB0 to PB7, this is the port B, and PC0 to PC7, this is the port C. This IC 8255, this the microcontroller of 8255, this IC are 3 ports, and these 3 ports are using 2 groups. 3 ports are using 2 groups. Group A and group B. Okay, group A, so 3 ports, 2 groups. These all are 8 pin, so total 0.4. So group 0.4 half is equal to 12. So one group, these are 12, another group, these are 12.
Hello, sir.
No.
Sir, আমার এনে স্যার
নেটওয়ার্কের সমস্যা হচ্ছে, সমস্যা তুমি পরে রেকর্ড দেখে নিও।
স্যার ফোন লো ব্যাটারি বন্ধ হয়ে যায়। ওকে স্যার, আসসালামু আলাইকুম।
সমস্যা নেই। Okay, so these are 3 port are using 2 group. Okay, group A now 12 pin and group B 12 pin. So must be 1 port are divide. Okay, this C port 8 pin are divide. This C port PC0 to PC3, these are 4 pin, and another PC4 to PC7, this 4 pin. Okay, so this group A means this port A 8 pin plus upper of C port 4 pin. All are clear? These are 8 and 4. This is equal to 12. Half of port C.
স্যার
হ্যাঁ হ্যাঁ দেবা
স্যার আবার যদি ওই যে স্যার 12 এর পরে থেকে যদি স্যার আবার একটু বলতেন।
হ্যাঁ, one group means 12 pin, another group 12 pin. Okay, this total port pin 24, but these 3 ports are using 2 groups, group A and group B. So group A 12 pin means port A, total port A pin 8, and port C upper part, this port C upper part 4 pin, 8 and 4, these are 12, this 12 is group A. And group B another 12 pin. Group B 12 pin is port B and port C lower part. Port B and port C, port B 8 pin and port C lower 4 pin. So this 12 pin is group B. All are clear?
Yes, sir.
Yes, sir.
Now this is the architecture. This just okay. This architecture, this is the group A and this is the group B. Group A controller, group B controller. Group A control must be port A full, port A PB, PA0 to PA7, full 8, okay, and must be group A, another control port C upper part, PC4 to PC7 upper part. So these 4 and 8, this is the 12. This 12 control, this 12 control, this is the group A. This arrow, this part, this arrow, this part. So these 3 complete, these 3 block, and another 3 block this group B control. Group B control, group B must be group B control, port B full 8 and port C half lower part, PC0 to PC3. Okay, so these 4 and 8, this is the 12 control group B. Okay, so 1, 2, 3, this part finish, and 1, 2, 3, this part finish. This is the 6th block is finished. Another, this is the data bus buffer. You know that our data line D0 to D7 and data bus also must be bidirectional. So this is the bidirectional data bus buffer. And this is the 6. This is the read-write control logic. This 6, we know that this is the shift selector, this is the reset, this is the A1, A0, and the read-write. This is the 6, and another 2, this is the VCC and ground. So this total 40 pins, and this is your block diagram. All are draw this. Okay, please draw your notebook. At first draw this. Okay, and just after 5 minutes I'll come. Okay, just you draw this. Hello.
Yes, sir.
So কি আঁকা শেষ হয়েছে?
শেষ পর্যায়ে
Yeah, here. Can you finish this block diagram? After this, your diagram.
Yes.
মশা কামড় মশা নিচে রাখা দিয়ে
So